carbon removal and mitigation projects and try to accelerate them by so doing. We are non-profit, so this is not this is non-commercial work and at an early stage. We like to look at areas that we think are either novel or neglected in some cases, that we think have gigaton scale potential. So we're pretty motivated to think about scale and large scale issues. And with that, I will ask Matt Donegan to first introduce himself, and then Megan Gavin, and then we'll get into our project.
Thanks, Anastasia. I think everybody can hear me okay. My name's Matt Donegan, and I actually live about 5-10 minutes from here in Portland, so short commute. I am a consultant, but come from the private sector. I spent about 35 years in large-scale forest project management across the globe. I was founder and co-president of one of the largest forest investment firms in the world, multi-billion-dollar fund with, again, a track record across the globe, but also with a very significant footprint in the WGA region, so fairly extensive experience here. And in my consulting practice, I think one of the kind of larger areas that I focus on is actually being a bit of a former insider to the public sector, to nonprofits, to try to help agencies better work with the private sector. And in this area, as Anastasia was just talking about, interagency, integrated, it's such a big issue that really the focus is on public-private partnership. And so I've worked pretty extensively on wildfire and trying to develop projects that really harness the power of the private sector and the public sector. And so that's what I bring to this case study.
Thanks, Matt. Megan.
Hi, everybody. My name is Megan. Thanks to the WGA for having us, and thanks for everybody in the room and online for hanging on with us through this session. I'm a partner at Cascadia Law Group, where I practice environmental law in Washington and Oregon. I work at the confluence of defending tribal treaty rights and bringing climate-friendly projects online. So my current clients include a startup doing marine carbon dioxide removal, a company doing underground transmission lines in Washington and Oregon, and of course the Carbon Containment Lab. I'm really excited to talk to you about their vision today.
Thanks, Megan. So, okay, let's get to that vision. This is our idea for what could happen in the Pacific Northwest. So we see a multi-industry integrated carbon management approach, and with really anchored around carbon storage in the Columbia River Basalt Group, which is a massive formation. And the exciting part to us as we started looking at this region and this potential is in around actually storing CO2 underground in such a way that it mineralizes. And actually one of the world leading experts on this process is sitting right in the room, Todd Schaaf over there from PNNL. So thank you for joining us. And we got, as a lab, very excited when we started reading papers by the PNNL team and others in Iceland who are pursuing sort of slightly similar technology, that this is really an approach to store CO2 underground, but whereby it mineralizes and becomes really truly permanent storage. And so we just thought this is very cool. This should be happening. This is potentially very large scale, so let's look at the regions in the world where this is possible. And of course, Pacific Northwest is one such region, and a really big one. So then we started looking at, well, what are the CO2 sources in this region? It is actually one of the unique things that it's a very clean grid in this region. There's vast clean power with the hydroelectric power, large-scale renewables and others. So there's actually not that much industrial and energy sources of CO2 in the region. So looking ahead a little bit, we could think about, well, what are the other two big resources in the region? We have clean energy, and that could potentially power direct air carbon capture, or DAC, facilities. In addition, there's the forests, and we're going to talk more about those forestry resources. This ties in a bit to the panel we heard yesterday on BECs or bikers. So bioenergy with carbon capture and storage, and associated, possibilities of using some of the waste residues and the residues coming out of these forests due to thinning from wildfire mitigation efforts, and what do we do with all that carbon that's embodied in that material? So are there ways of building up an economy around that system, but also other aspects as we're able to get this off the ground? So as a lab, when we started in January 2020, we started looking at this. It was actually right on the heels of those big wildfires in Australia, which is where I'm from. And so we got really fascinated with wildfire and concerned as well, and really thinking about it from many perspectives, including the carbon emissions associated with the fires themselves. And then with the associated activity of trying to address wildfire and thinning forests and so on, again, this question is, what are we going to do with this massive amount of carbon? Is there something really productive we can do that can help rural economics, that can help the region? And can this be done kind of responsibly and sustainably? So on the sustainable front, a big question is the economics. How do we think about these sorts of visions? Because they are broad, they're going to involve many different, parties coming together, as well as quite a lot of capital investment, because some of these facilities are greenfield, some of these are new. And certainly we want to look at existing infrastructure that's already there, ways of either moving water around or minerals around, or moving CO2 around, what's actually possible. So as a lab, what we've been doing is sort of systematically trying to understand and map out and think through the economics of this approach, others that are now emerging. And we've honed in on a couple of areas where we have a bit more expertise, knowing that others are working on direct air carbon capture. We're like, that's great. We don't actually have a lot of expertise in direct air carbon capture, so we're hoping that the DAC hub that was recently awarded some funding from the Department of Energy in the Pacific Northwest will really bring a whole group of different DAC companies to the region, and then we can start to sort of co-locate the sinks or the storage resource with the capture of CO2 from the atmosphere. In the case of bioenergy, we're talking about the plants themselves, the trees capturing that CO2 for us in nature-based approaches, but then you have to convert it into something that can be usable either as an energy product and or separating off CO2 to be sequestered underground. So similar sort of approach to what we heard from Moat yesterday, and there's some other companies exploring that in other parts of the country. So there's a lot of work to be done here. This is pretty early stage research, if you like, and analysis and feasibility assessments that still need to be done. In parallel with the more technical and economic analyses, of course, thinking about, well, what's already going on in the region, what are the priorities of this region, what are the people who live there and the tribal nations who the long-term stewards of this place, what are they seeing ahead in this region? And so we've been taking the time to speak to people and learn and read books and history about the region, and really try to understand. It's a very rich, very complex natural resource sort of situation in this region. So before we get too far ahead in pushing a particular technology or a particular approach, we thought it was very important to take the time to do our homework and really learn and understand and ask all the questions. So we have sort of started to build this vision. I mean, this is a really overly simplified diagram for you today. It's a lot of analysis and complexity underneath all of this. But it is helpful just to give a sort of schematic of what we're talking about. So on the wildfire side, let's start there. And, when we were getting a sense of just the extent of the emissions that are already happening and potentially could be generated through, intervention on wildfire, and what is the potential for that CO2, we turned to Matt Donegan, who we were fortunate enough to know from a prior life in the investing space, and he really educated us on what's happening in this region. So What I'd like to do now is turn to Matt and say, okay, can you tell us what is specific about the forests in this region that in the Pacific Northwest as they pertain to decarbonisation strategies or in, any of this vision? Can you just tell us a bit more like what we need to know to understand what's happening in the forests in this region? Matt.
Okay, thanks, Anastasia. I guess a place to start would be to say that I did chair the Governor's Wildfire Council here in Oregon a few years ago and took a very deep dive on Oregon wildfire policy. A big part of that was looking at the source of the wildfires, including the fuels, public lands, private lands. And so had the opportunity to look fairly deeply here at one state. But at the same time, I do serve on some national and global panels, including the Yale School of the Environment has a bioenergy initiative that I'm an advisor to, and the same thing with the Energy Futures Initiative. So I've had the opportunity to both look kind of deeply here and then be able to look across the country and for that matter the globe, so I can kind of contrast with how this region looks relative to other areas. And I will just say, the BECS initiative that was discussed yesterday, and for that matter offsets, these are all very familiar projects and initiatives in other regions. This area is definitely unique, and I see a lot of private investors get very excited, come to this region looking for BECS opportunities, and then it's the same pattern over and over again. They get out here and they see just how different this area is relative to other areas that they've been looking at, and frankly, a lot of times they get scared off. And I think the very significant difference between this area being the whole WGA footprint for that matter, is the very, very significant role of the public sector across the whole, across this industry. And you see that, with the Forest Practices Act, the forest regulations. This is, I think, the most regulated forest area probably on Earth, certainly in the United States, but also the ownership. And in as much as the wildfire issues are fairly concentrated on the interior side, not entirely. We are seeing wildfire moving west, as we saw in 2020, the west side of the Cascades. But for the most part, the more frequent fire activity is on the inland, the dry areas. This is an area that's particularly dominated by public ownership. Here in Oregon, I think 60% of the forests are owned by the federal government. I think 25% of the entire state is owned by the federal government. I think on the interior side, on the east side of the Cascades, it's much greater percentage. And you see that across the WGA region, just very, very significant federal ownership. And as wildfire chair here in Oregon, what we saw was that if you look back over the last decade, about 93% of the burned acres here in Oregon occurred on federal ground. The prior decade, it was 93%. In the prior decade, it was 93%. So it's a pretty significant and consistent pattern that if you're going to deal with wildfire, if you're going to deal with the wildfire crisis here, you're going to have to address public land ownership. That's kind of inescapable. And anybody who knows anything about federal forest policy knows it's a very, very significant challenge and has been for decades. And so I would say that is one very significant distinguishing factor, is the need for public sector ownership. I actually have long thought that the WGA can play a kind of a unique role in that regard in terms of leadership on public lands. So I would say that is a challenge, I think a fairly significant challenge. On the other side of it, compared to other regions, BECS projects are often looked upon in terms of social justice, environmental justice, as being kind of on the negative side of the ledger. There's always concerns about what are BECS projects going to do, what are bioenergy projects going to do in terms of low-income communities, vulnerable communities, and so forth. Very, very different discussion once you turn to the west, because in as much as wildfire disproportionately affects vulnerable communities, then the benefits disproportionately accrue to vulnerable communities. And so you're looking really at, by and large, kind of a public environmental a positive environmental justice, a positive social justice, aspect here. And that, I believe, makes this a, potentially a very promising bipartisan, issue, bridging urban and rural communities. Here in Oregon, very kind of famously, we've had a couple of bites at the apple on climate legislation that did not work. During this exact same time, we've been socializing this project all across Oregon, and I think with unanimous, and across the Northwest, with unanimous bipartisan support, because the public value proposition of wildfire mitigation, climate, job creation is pretty darn compelling. And so I think the big picture is one that's very promising in terms of the opportunity here to do something meaningful. The challenge, as Anastasia was saying, is just the dominance of the public sector. And I would say, the last thing I would say to that, it is the interagency aspects of this. If you really look at the org charts, if you will, across state, federal, where does this all come up? Energy, wildfire, forests, it's not always clear. And so how does the private sector plug into the public sector, find that leadership for kind of integrated solutions is often, what we find to be the challenge.
And on the forests themselves, we did some analysis at the lab, which was then incorporated into the Roads to Removal report that you heard about yesterday, published by the Lawrence Livermore National Lab. I won't walk all the way through this, but we were trying to calculate just how much CO2 equivalent are we talking about here, potentially. So we were looking at FIA data, forest and inventory and analysis data. We thought about, if you were to take sort of low-value woody biomass, that removing that from the forest through mechanical thinning, just in high-risk locations that have been identified by US Forest Service, and make some pretty conservative assumptions about how much you're pulling out. There's actually a huge volume of biomass potentially available. And if you then convert that to the equivalent of in terms of CO2e, we're getting up to 2 gigatons, and this is massive. This is like something that is really overlooked as a resource, and yet many steps to take in actually doing this work. So Matt, if you look at this type of analysis and these sorts of numbers, what do you see right now?
Yeah, so one of the bullets that you'll see towards the top is the Forest Service Wildfire Crisis document. It came out a couple of years ago, and it is a call to action for an additional 50 million acres of land to be treated across the West over the next 10 years. To give some sense of magnitude, that is an increase of anywhere from 5 to 10x. This is incrementally. That's the federal policies, and at the state level you see oftentimes even greater increases that are being called for. We're seeing that magnitude it's being called for here in Oregon. I think in California, CARB is looking at different management scenarios, specifically from a carbon perspective, and actually the outputs are coming in even higher than that. Whatever the magnitude is, this is historic, and I think it's important to talk about what do we mean by fuel treatments. It's generally two types. It's prescribed burning, but also mechanical thinning. And it'll be kind of a site-by-site basis as to which one of those prescriptions work. But with prescribed burning, you won't have biofuel as a byproduct, but certainly with mechanical thinning you will. And under any scenario, you're talking about a historic increase in biomass availability. A lot of that right now is stacked and burned, and which has its own set of issues, including emissions, residual fire risk. So the question is, how can we get the biomass out of the forest economically? And this has been a long-standing challenge on biomass because it's so low valued. And so I think to a certain degree, one of the opportunities here is to the extent you're integrating with the basalt and creating a new revenue stream from carbon capture and storage that potentially could unlock, very significant revenues to help pay for this restoration work that's coming.
And do you think that this is a funded mandate already, or is there still funding that's needed
Yeah, no, it's
to support this sort of thinning?
This is a fun conversation because when you talk to, whether it's the Oregon Department of Forestry or Washington DNR or the Forest Service, these are kind of the best of times in terms of funding because we're looking at things compared to historic levels. But when you look at it compared to these policies, we're not even at a fraction of what these policies are calling for, and they're not. We don't have sustainable funding sources. So right now we don't have nearly adequate funding for this mandate. What the Senator Heinrich from New Mexico recently led a study that estimated that the current costs of wildfire across the West are somewhere between $400 and $900 billion annually. And so what we're trying to do is figure out, okay, if you project that out in the next 20 years, that could be, $10 trillion. What is the value proposition of conducting these thinnings? Can you mitigate some significant portion of these several $1 trillion that we're confronting, particularly trillions of dollars that are going to be disproportionately impacting vulnerable communities? Is there a way to make those investments on the front end so as to mitigate a portion of those of the costs that we're expecting?
Great. Well, I'm going to switch now to talking about rocks and geology, another aspect of this project, and thinking about the Basalt Group, which I'd mentioned is this really large-scale resource. Let's see if we can get the next slide. There we go. So I mentioned the Columbia River Basalt Group. This is a series of lava, flow formations in the region. The outline in blue is the sort of large extent of these flows, and you can see right in the middle there is the Columbia River between Washington and Oregon. And in green is where the depth of those different formations seem likely a good place for sequestration if you're going to put supercritical CO2 down very deep into these formations. This seems to be the area. Now, a few things about this. It is one of the largest formations of this type of basalt in the world. There has been a bit of exploration here, but this is not an oil and gas rich region. So there's still quite a lot to be known. There's not been a lot of drilling at the sort of depths in this region compared to other parts of the country. So you can see it's a very large area, so it's like potentially huge, but we need to know a lot more to be really able to cite all sorts of carbon storage locations in this region. But as I said at the beginning, the cool thing here is that if you do inject supercritical CO2 into these formations, what's been shown by PNNL's test well at Wallula is that actually the 60% of that CO2 mineralized within 2 years. And so this is actually quite, in a human timescale, pretty rapid. The mineralization process sort of immobilizes and permanently locks in the CO2 within the pores of basalt. What we're talking about here is actually injecting into the breccia in between the layers of basalt. So basalt's very hard. And so each of those layers, almost like a layer cake, is very thick and very hard and forms a very good cap rock. And so because there's been just one test injection in Washington, a lot is known from that, but it was at a relatively small volume of CO2 of a bit under 1,000 tons. More testing is actually needed. A lot more research is needed here to both understand and characterize the basalts, as well as model the mineralization process and model the sort of plume radius and where it's going to end up. Make sure that you're not inducing any seismicity issues or causing any problems. Really understanding, the best locations to do this and honing in on that. But there is a potentially very significant and very large resource available. So, this got us excited. We started to look at permitting regimes. So in the US, under the federal EPA program on underground injection control, they have a Class 6 permitting process. I'm not sure how familiar you all are with this, but it is a very extensive permitting regime that requires a lot of work in order to actually permit a single well for injection. And to better understand the timelines of any and all permitting, so not only the Class 6 wells, but also many other permits and approvals, we had Megan and her team work on a whole permitting overview for us of like what it would actually take, like how many years are we talking about here, what's sort of ahead, and are these different government agencies really knowing that this might be coming. So Megan, could you describe to us some of those key permits and approval processes for underground injection and associated infrastructure? I can get your slide up there. Yeah.
Thanks, Anastasia. Before I begin, I want to caveat this a little bit that this is just for the sequestration part of the Carbon TrapRock vision. This doesn't also include if there were to be co-located DAC facilities or bikers. We have undertaken the bioenergy analysis, so if you are interested in that regulatory approvals and permitting process, I'd encourage you to follow up with Anastasia afterwards. If there is one thing that you take away from this slide, I hope you take away that there's much more involved in these types of pilot projects than just a Class 6 injection well. And so as Anastasia said, it is a time-consuming process, and I'll walk you through the most critical of what's here on the slide for you. So I want to start with tribal outreach and engagement. Obviously, that's not a law, but we want to underscore the importance of yesterday's panel, that it is important to respect tribal treaty rights and make sure that you are not adversely impacting tribal treaty rights or cultural resources. And that has been very important to the CC Lab as they've undertaken this vision. Much of their work to date has been on the engagement front, because once you have cited your project, once you've made a decision around citing, then your alternatives analysis is limited to go, no go at that site, and you haven't taken the Indian tribe's perspective into account of whether they welcome your project at that site or not. So we've undertaken some outreach and engagement with those tribes in the area and with CRTFIC, which is the Columbia River Intertribal Fish Commission, to reduce the impacts on just going to individual tribes over and over, but to go to an organization to make sure that their priorities are taken into account in this vision if it were to get off the ground. So the first thing that we needed to think about when this project came forward was the pore space issue. This is a question of whether the surface and mineral estates have been severed. There's no easy legal answer to this question. Washington and Oregon don't have laws on it. There's no federal law, but case law indicates that under the American rule, the owner of the surface estate would own the pore space. This makes sense because the pore space is the absence of minerals, so why would the mineral owner own the pore space? But it's somewhat of an open question at this point in time. It's made even trickier because of the Stock Raising Homestead Act, which affects us in the western states. The Stock Raising Homestead Act applies in areas of the West where the federal government gave away surface rights but kept mineral rights. It's possible that the federal government could argue they also kept the pore space. They haven't spoken to this question. There's no easy, convenient way to figure out what parcels in the West are SRHA impacted parcels. They're kind of like popcorn all around the West. So for the WGA, having clarity at the state and federal levels on pore space ownership would reduce the risk to project developers trying to do sequestration projects in the CRBG. That could reduce their risks so they know who to negotiate with for ownership rights and so they don't face a trespassing action. The next law that I'd want to bring to your attention is the National Historic Preservation Act, the NHPA. I'm sure most of you in the room are familiar with NEPA. The NHPA is the cultural equivalent of NEPA. The NHPA we found would be triggered by this project because there's a federal nexus here. That would be the EPA's issuance of the Class 6 permit and or funding from the US DOE. Section 106 requires federal agencies to stop, look, and listen before they take an action related to a project. So here that would be making sure that historic properties aren't adversely impacted, and historic properties include traditional cultural properties and traditional cultural landscapes, which are can be vast view sheds. They're areas of significance to Indian tribes. And this can be a little complicated because those areas are often kept confidential. So from the very beginning, the Carbon Containment Lab retained an archaeologist and cultural resource specialist who worked with us on this project. I would next take you to NEPA. As I said, the US EPA's issuance of a UIC permit could trigger NEPA, but we found that it would not because this action of the permitting the Class 6 injection well is under the law functionally equivalent to NEPA. So you're already undertaking what would be equivalent to a NEPA analysis when you go through the UIC permitting analysis. But NEPA includes environmental justice protections that the UIC process doesn't. Those are cultural, economic, social concerns, and therefore the US EPA encourages applicants to incorporate those aspects into the UIC permitting and decision-making process. We also needed to take a look at the US DOE's funding here because that would be another federal action potentially triggering NEPA. We found that there is a categorical exemption, but it may not apply in this case, meaning the Carbon TrapRock Project would need to comply with NEPA. The categorical exclusion is if no more than 500,000 tons of carbon dioxide is injected over the life of the project, and if there are no extraordinary circumstances. It's possible that there would be extraordinary circumstances here because there could be scientific controversy over the appropriateness of a protocol of injecting into basalt, given that it would be a first of its kind project except for the PNNL team's work. I'm going to move us now to the Safe Drinking Water Act. And I will mention that Washington's SEPA will apply. There's no categorical exclusion there. So I'll move us to the Safe Drinking Water Act. This is where your Class 6 well would come, your Class 6 injection permit would come. Under the Safe Drinking Water Act, the EPA has established minimum federal requirements for protecting underground sources of drinking water. There are 6 programs based on well type. We were actually interested in 2 well types, Class 5 and Class 6. Class 5 is a catch-all category, and it includes experimental wells. These are wells that utilize a technology that hasn't been proven feasible under the conditions in which it is being tested. We thought that that could be a great fit for an injection in basalt. We also thought that could be a great fit for an injection in basalt because Washington has primacy for Class 5 wells, and Washington defines Class 5 wells as including wells specifically to inject carbon dioxide. We talked to the EPA, we talked to ecology, we talked to Oregon. We found out we would need both. we would need a Class 6 well from the EPA and a Class 5 permit from Washington. Don't extrapolate that beyond this project. That was based on factors of this project, and as the project definition changes, that could change. Also, while I'm here, I want to just take a moment to say this table that you're looking at on the slide is just structured in a general way. The Safe Drinking Water Act obviously also has pre-injection aspects that you would have to comply with. So it's an authorization to construct permit. You can't even start building your wells until you're permitted, and it has monitoring and reporting obligations. Another interesting one here is RCRA. I'd like to specifically call this out for the WGA. Washington and Oregon have delegated authority to enforce RCRA. RCRA is our federal law for managing dangerous waste. It exempts carbon dioxide injected into Class 6 wells if the carbon stream is captured from an emission source. It's silent as to carbon directly captured from the air. So there is a hole here where if this project were to use DAC, then RCRA permitting would also have to apply, and RCRA is onerous. I think in the interest of time, maybe I should stop there.
Yeah, do you want to just give a quick overview of this, what's happening at EPA with Class 6 wells in general across the country?
I can say here that Louisiana, North Dakota, and Wyoming have primacy for Class 6 wells. A way to go to those states. But the takeaways that I'd like you to see are that the western states are very well represented on this chart. Although the CRBG is underutilized, we can see we have no permits pending for Washington and Oregon despite this resource. And the last thing that I would add is the permitting process used to take 6 years on average. The EPA is trying to get it down to 2 years. From the chart, it looks like it's more about 2.5, but this chart leaves out all of the legwork that needs to occur before the preparatory work with your tribal engagement, your analyses that you won't be impacting endangered or listed species, et cetera. And so tack on a good 2 years before this process, and that would be on average how long it would take for one of these projects to come online.
I think the other observation I would have is just there's a lot of projects in the queue. These are typically managed by the regions, EPA regional infrastructure, but headquarters is guiding and helping them along. There are some questions to do with the applicability of all of the Class 6 requirements for basalt. Only there's one or two areas that need some clarification, and EPA is aware of this and hopefully working on it. To give some guidance for basalt in particular. But what strikes me is just like there are a lot of projects out there and there are none in this region. But I think there are some people, hoping to change that pretty soon. Getting some engagement with EPA on basalts, as well as just in the EPA Region 10 in this region, to sort of talk to them about this permitting process, make sure they're aware that projects may come, and getting them sort of motivated and organized has actually been really fruitful discussions. We were able to do that long before any sort of project comes their way, so that they know it's coming and can gear up if they do receive an application. So I think another aspect of the regulatory and permitting review that Megan shared with us was that nearly all of those processes require engagement of stakeholders and tribal nations. And so that's asking a lot of these different groups in this region to be engaging through each and every one of those permit sort of approvals processes. So one of the things we did as a lab was work with a professional planner and project manager who's worked on very large scale complex projects in the Pacific Northwest, to create a kind of really detailed Gantt chart of all of those permitting regimes and which ones need to have consultation at what stage, and try to kind of line it up as much as possible so that you're not overburdening different communities with your requests for engagement and participation. Also thinking about some of the best practices we heard yesterday about, you know, having capacity building and funding grants and so forth, so different organizations can actually meaningfully participate and have the staffing to do so. So that's part of our thinking there too. And on that front, Megan, you have a lot of experience working with different tribal nations in the region. Are there any particular call-outs for best practices that you'd like to make now? And having heard the panel yesterday, anything you'd like to reinforce from what was said?
Well, echoing all the points yesterday and those that I said earlier that the Carbon Containment Lab engaged in, I would say Anastasia was just talking about consultation. I'd make the point that that's consultation between government to government. The tribes are sovereign nations, and that's embedded in the laws. But it's important for project developers to engage in their own consultation if the tribe is willing to do that with them. We call it informal consultation because obviously a project developer is not a government, but that's an opportunity to hear what their priorities are, what their needs are, and then if you do it early enough to incorporate it into your project design, and I've seen that worked very, very successfully on other projects. This one isn't quite that far along yet. So early and often, and staying in frequent contact, we sent letters updating tribes on the status of the project at every major milestone, always welcoming conversation.
Thanks. Yeah, it's been particularly interesting and actually really meaningful to have those conversations and to learn about what's happening in the region and the concerns. And not all of the concerns and the things that tribal nations are working on are going to be directly benefited from this kind of a project. But there are some touch points, and you know, just that very long-term view that the tribal nations have, and the historic view as well that they bring to the table. It's incredibly important to understand. You know, especially if we're relying on some of the existing energy infrastructure of the region that they've, you know, had issues with, rightly so, over the years. So we need to really understand what's that, you know, what does that look like for them? And it's just been, yeah, a really great dialogue. I won't say, you know, don't want to oversell this. It's been, you know, hard on our end. We've spent a lot of time trying to have conversations. These are very busy people and they have all sorts of other things going on. But it's been great and very sort of rewarding for us to learn, basically. So I want to jump us back up a level, back to our schematic, and I think we have about 10 minutes left, a little under, so I do want to turn to sort of policy. So we've already heard some specific ideas. I think in the room you're all going to have other ideas and or questions. So just if anyone has something burning, please raise your hand now, and then I'll get that going. I see 1, 2, 3, 4. Yay, okay, well, good. I had some, but I would love to. How about we start right here? Yeah.
Sorry, test. Okay, great. Thanks, guys, for that. Appreciate it. I think my question would be more for Megan in terms of you addressed the minerals and the pore space rights. Just curious to know if you guys have identified any perhaps legislative champions and state legislators or even the federal side, congressional folks that might look into creating a legislative workaround for that, or that kind of provides clarity to enable projects like this to move forward.
No, we haven't. This project was really just at the analytical level for our team, but having clarity from the federal government on their position on the Stock Raising Homestead Act would be critical, and then actually pore space ownership, I think, would be within states for them to set.
Thanks, Bill Drumler, Washington Department of Commerce. The schematic is great. What is missing, of course, is that all those bottom arrows are really infrastructure.
Yes.
They're pipelines, they're truck traffic, they're whatever. You know, the legal overview was interesting. My understanding of that's really just at the point of injection, not sort of taking into account, you know, having to put in place, CO2 pipelines probably across the geospace here. So yeah, I'm just kind of curious. This is not a new concept. I mean, I'm old enough to remember West Carb, which was from the early 2000s, which did a similar kind of analysis. But it all, where the rubber hits the road, or doesn't, as the case maybe seems to be with the infrastructure. And I'm just kind of wondering if you sort of have a new take or a new approach to sort of, hurdle that hurdle.
Yeah, I'll say that we have done some studies of different ways of moving CO2 around, whether that's by pipeline or trucks or rail, even barges, just to see what's technically feasible and the costs associated with that. We dipped our toe into understanding, what the social kind of license, as it's been called, or attitudes towards moving CO2 around is, and it's kind of a little scary, frankly. I think that's going to be the part that faces the most resistance, and ideas are welcome on that one. You can do some GIS type mapping exercises to see what the best sort of routes would be, and if you can follow existing rights of way and that sort of thing to make it as least disruptive as possible. But I still think there's a lot of groups and individuals who will not be happy to see this. And this is not unique to this part of the country. Other parts of the country have faced similar, challenges and concern over moving CO2 around in this way. We don't have specific sites lined up and ready to go. We're not project developers. So in the end, it's going to be about sharing this kind of information and making sure that the geologic work is done and progressing, because it takes so long to do those sorts of studies and so on. So jumping ahead, you're right, we need to be thinking about this, but we don't have some magic solution there.
I would add one thing, that on February 1st, PIMSA put out a proposed notice of rulemaking for improved pipeline safety. So I'm curious to see what those public comments will be in response. We'll see.
Todd.
Hey, great panel. It should have been the very first one. That's my thought. I've been in the business for 20 years, so I'm deep into the science. This is for the panel. What do you think is the number one barrier that is preventing us from moving this forward? And I'm involved in the science. I live in the community. I'm at the National Laboratory. So we love this concept, but what is that barrier or barriers?
I'll start, and I would love to hear your response to that too. I'm sure you have one. I think number one on the geology side is funding to do more characterization. That is under Department of Energy has this great program called Carbon which pays for drilling and characterizing before pre-injection, before you're doing anything. But you do need to raise 20% cost share of that, and drilling's super expensive in this region. And that's a real challenge when you don't necessarily yet have a commercial entity coming in and wanting to do a project. So you have this sort of problem of like, we don't have enough CO2 capturable in this region, but we want to do all this characterizing work. So if we could have some sort of a program that is about regional study and doing it right and really looking across all the different regions. As I said, there's a big green, area. There's a lot to explore here that's less tied to sort of commercialization at this point in time. I think that would be extremely helpful to move this whole system forward. And then all of the associated scientific work that goes along with that. I think that would be a huge unlock for this region, particularly on the geology side. But Matt, Megan, what would be your number one?
I would say leadership. This is a massive integrated vision that's multi-state, and you need somebody to pick it up and take the reins. I think that needs to start at the highest levels of government.
Mm-hmm.
I think that would have been my response as well. I think maybe, Todd, something I can add, and I know you've been at this for a very long time. I have been struck by the positive response that we've received from the private sector. I think this, that was a big unknown for us. And whether it was landowners, and we, canvassed all the landowners that, around this core area, and the response was, very, very favorable. And I would say it's the same thing, with regard to bioenergy. Certainly private forest landowners, and I would add, talking to the federal agencies back in DC, on the forestry side, they had never heard of this concept before. We laid out these schematics and they were blown away. I mean, so I think the conceptual reaction, and I would add, elected officials as well. So I think the excitement that you feel, we have felt, and I think it's reasonable. It's a very, very compelling argument, particularly when you look at wildfire, climate, rural economic development, so many areas that have just been devastated economically over the last few decades. I mean, there's a very compelling public value proposition, but to get a pilot project, just a pilot project, I mean, the CapEx is so significant from the private sector. You're going to have to de-risk that, and that is going to take kind of one-stop shop leadership from the public sector, somebody that's just going to own this, work in partnership across the value chain, including pipelines and, the infrastructure. But the private sector is going to need a very reliable public sector partner to pull this together.
Was there one more? I think we have time for one more, and then we should wrap it up.
Ooh, I made it just in time. And actually, Angela Seligman with Clean Air Task Force, Todd had the same question that I did, so I'm just going to tweak my question a little bit and maybe take a step from there. And thinking about what those major barriers are to getting a project like this moving forward, what you all think are the next sets of policies or funding or regulations that would be helpful to move something like this forward to try to start overcoming those barriers?
Megan, you had mentioned a couple of specific things on pore space and so on. Is there anything in addition that you think?
I think I'll need to think if I have anything more to say other than the pore space and the RCRA exemption.
Mm-hmm.
A critical barrier, it's been said a lot, but building the tribe's capacity to engage in a project like this from the very beginning. We've tried to think about it, but you also don't want to risk appearing as if you're buying tribal treaty rights. And this isn't a check the box exercise, so how to do that engagement meaningfully and respectfully is, building their capacity is also a barrier.
Anything to add?
Yeah, this is kind of right where this project sits right now, as we're asking just these questions. And I think a lot of it, a lot of what we're musing right now is what is the right, organizational design from the public sector standpoint. I think, if we could draw up a dream scenario, I think where we've landed is that the bioenergy investment, whatever that might be, sustainable aviation fuels, gasification, is somewhere kind of where it all is the hub. It's where everything kind of comes together. And so if you kind of backcast from that, go upstream with feedstock, biomass, working on a pilot project where you're circling the highest wildfire risk areas, on federal ownership, inclusive of non-federal ownership, tribal ownership, private ownership. But so you have leadership on that side, and then downstream with all the geology and pipelines, and so forth. But to have kind of to circle an area for a pilot project, and with a focus on what is it going to take for us to attract the hundreds of millions of dollars, if not more, of private investment in order to pull that together.
Do you mind if I?
Yep, sure.
I can better articulate my last thought there, not to call out Washington, but we heard yesterday about the capacity grants, and those capacity grants are limited to tribal lands. Tribal lands is a definition that does not, at this time, include the historic and traditional lands of the tribes. So a project like this, for example, would not be cited on reservation lands at the beginning out of wanting to make sure the project was safe, worked functionally well, et cetera. But it would be on the traditional lands of many tribes. So if there was an opportunity to expand the definition of tribal lands and to give capacity grants to those tribes as well.
Well, I just wanted to close by saying, you know, obviously we've presented something of a very big vision. We like to think big. We think the climate change challenge ahead of us is that big. And it's going to take many, many solutions. Here are a subset of them that we think can come together, but there are going to be others in the region that make sense, and there's going to be others that are emerging as a lot of research and development money and people are coming into this space and coming up with all sorts of ideas. So there's work in the region on mineralization underground, but also above ground. There's work on all sorts of ocean and blue carbon projects. So it's an exciting time. We're meeting and talking to lots of really interesting people. So I thank the Western Governors Association for giving us some time here at your meeting. And we look forward to further conversations. Thank you so much.
Thanks, Anastasia. All right, I'm just going to real quickly close this out. So to conclude this workshop, which is our final initiative workshop, I want to once again extend my thanks to Governor Kotek for hosting us here in Portland this week. I'd also like to thank Governor Gordon for his continued commitment and leadership on this issue. I would like to recognize our initiative partners, including Basin Electric Power Cooperative, Google Energy, Idaho National Lab, JP Morgan Chase, Net Power, Tri-State Generation and Transmission Association, and the Walton Family Foundation. This work would not be possible without your contributions. Looking ahead, while this is our last workshop, we will kick off our webinar series starting next Wednesday, March 20th, 11 a.m. Pacific time, 12 p.m. Mountain time. We will be exploring liabilities for long-term geologic storage, and we have some fantastic speakers lined up, including folks from the University of Wyoming School of Energy Resources and the North Dakota Industrial Commission. You can find information and registration for that on WGA's website, and we'll also put information for future webinars up there as well. As this is our last workshop, I would be remiss if I didn't very quickly but sincerely recognize the WGA team who are both here and back home in Denver, from putting on these workshops, running the webinars, developing the report. It takes a lot of time and effort, but this team, it definitely makes it look effortless. So thank you. To all of you still here, thank you for tuning into the live stream and being here in person. Thank you for participating in these conversations and these discussions, and your continued support of Western Governors. Safe travels home, everybody, and hopefully I'll get to see you and work with you some more.